Hi, I'm Andrew Armstrong. Welcome to the back office teardown lab. Another mystery kit from China, and this one looks humongous. Look how many parts it's got. Let's have a look at the instructions just in case we can glean what it might be. Yeah, we're not going to learn too much from this apart from 50 to 5 kilohertz. Here's the circuit. Let's zoom in. Maybe we can tell something from here. So you've got some power in, and then you've got two outputs, an X2 and an X3, and then this ICL8038 chip. I suspect the ICL8038 chip is something amazing. I've got my oscilloscope set up, so today we can actually measure things. So let's just build this, and we'll plug it in, and we'll start probing, and maybe we'll try to figure out what goes on these outputs. Let's begin. PCB. Zoom out a little bit more so we can have a look at what we're doing. PCB looks clean and good enough. Few resistors on here. You know how I hate resistors. Great, that's going to consume a bunch of my time. But let's not worry about those just yet. I always put those off till end anyway. LEDs. A pot. There's your big IC right there. Let's just check that out again. ICL8038CCPD. That's it if you want one of these guys. So little switch, lots of variable doodads, some capacitors. There's not too much here. It shouldn't take too long to assemble, so we should just jump right in, really. What will I start with? You know, shall I bite the bullet and just start with some bloody resistors? Go on then, why not? So look, I'm just going to order them out while I can into their sort of various colour bands, so at least I don't have to probe them all. Look at them, look at bloody resistors. They're so confusing. Those look the same. Those look the same. Actually, is that only two lots of values? Two values a resistor? Doesn't seem right. You should have a 10k, 200k, 4, 5, 6, 7, 8 resistors in total on this circuit of those values. So let's see how many we've got. 4, 8. So there's 3 of one kind and one of the other. So this is the 200. These 3 are the 10k, and these 4 are the 33k. Marvellous! That makes my life a lot easier. So we'll just jump straight in then. So let's start with our 33k resistors. These 4. Pop them down here, out of the way. So I've been enjoying these kits. Still got a fair few left in my bag. These are sort of getting to the more esoteric ones though now, where I'm really not sure at all what they do. Looking at the PCB while I'm trying to thumb these into these holes, it says www.66kv.com in the top right corner. 45 by 60 millimeter. That's really all it says. That's the probably the manufacturer of the kit, or just at least the manufacturer of the PCB. I'm going to solder these bad boys right now, just to get them out of the way. I'm going to try a different technique. I'll show you. I'm just crossing the legs. Normally I splay the legs, but today I'm going to cross them. See this cross fashion. See how that holds them in. I'm sure over the years I've tried that, found a reason why it's not so good, but soldering iron tip cleaner was miles away today. So yeah, I'm using this chopping board. So far so good. I'm kind of liking it really. I'm not sure how it will withstand heat damage. Yeah, it's a bit melty, but it looks like you could probably sand it down again if you need to. Just a bit of sandpaper. So I'm going to use this. I'll show you this. You'll like this. See my little drawer here? I'm going to try to aim all my filings and bits and pieces off camera now, so they'll be in the drawer. And if I don't do that, look, I can do this as well. Brush it into the drawer of rubbish. So yeah, I'm really hoping this works out. You can buy these chopping boards off eBay, of course, or Amazon. They were reasonably cheap, but the material is actually quite good. It's quite good as a chopping board. So you could always get one for your wife, assuming she's doing the cooking, and then you know, pinch it when she's not looking. I think the idea is that you sort of chop up all your vegetables and then you Hang on a cotton picking minute. 3 10Ks. Yeah, I almost popped that in the 200K hole. That would have been a bit weird when I sort of had to sort of do some debugging. Hang on a minute. Am I losing my mind? This one is the spare 200K, but it looks like it's the same color as those, which is the same color as that guy, which is the same color as that guy. Time for a probe. So these are the 33K resistors, and that's the spare 33K. Oh yeah, there we go. So that must go in there. I've just, I must have just lost my mind talking to you. Lost track of where I was. I thought I was shoving in the 10Ks. So let's crisscross that. Off. Okay, so we've got 3 lots of resistors here. That's the odd one with its red band. That will be the 200K that will go here. And then we could just throw all the rest in. I'm just gonna... The crisscross thing works with the legs, by the way. It's pretty good. Just don't bend them over too much, because you're gonna have to be like a weird diagonal thing going when you have to cut your legs. Just gonna throw you a bit. But yeah, whatever works. If that works for you, just do it. God, it's a bit fiddly. One of these days we'll do a surface mount construction. You can just see how it differs. You're just picking and plopping pieces on top of the PCB, and then you sort of heat the whole thing in one go. So you sort of put up all the construction up front and investment at the beginning. But it's quite a fun way of doing it, and there's different techniques. You can either just do it manually. You've got these various stencils that you'd get sent when you make your PCB. You can use the stencil as well for the sort of solder paste. Or if you want to, you can just do it all by hand, a little bit like we're doing right now. I'm going to try chopping the pins here. I know I've said it in one of my earlier videos, these bits you cut off, these old legs, I know it's nice to sort of just chuck them away, just sort of get them recycled, but sometimes keep hold of them a little while, because you can they're ever so useful when you need a jumper. Right, so that's all the horrible resistors out of the way, so everything else is nice and easy for us. So we've got 2 ceramic capacitors, a 102 and a 103. Fortunately, you can see they're quite clearly labelled on the components themselves. So there's our 102 and there's our 103. So we'll just pop those in, nice and easy. C5, 102, C4, 103. See, the camera went a bit blurry there. Wasn't happy. C3, a 104. Now I did say those 2 I just put in were ceramic, but I guess, I don't know now, maybe they're a different material. Please correct me, what are these ones? What are those caps called? I know they do have another name. And if you do know, tell us what the properties are. I do know at least one of you watching this channel is an electronics university student, so you should know. go. Almost there. Taking my time a little bit with those. I don't really want to spend too much time debugging PCB because I didn't take any care. Let's clear the deck, start again. So all that's left now, there's the one electrolytic, I can see that, a couple of switches, a switch, and long leg plus. Remember, long leg plus, we've been going through that a few times, haven't we? Long leg plus. LED. Let's put in these variable resistors. They're 20k and a 100k, so that says that's, if we're going to make a guess, that says a 203 and a 104. Yeah. I'm just going to assume the 203 is the 20k. And the 104 is 100. If not, we're going to have a lot of fun and games. In fact, I'm going to buzz those out first. We don't really need to guess, and I'll show you how we buzz those out. Let's get those other bits in. Just going to tack those, straighten them up. Getting that LED pushed through. So you can see the LED's now sitting flush. Bit of solder. So while I was in the car boot cell today, I did notice a few odd old bits of kit. Not too many games consoles, but I might start getting some games consoles in and seeing if we can... Oh, I think I've just worked out what this is, by the way. Have a look here on the PCB with me. Power in, ground, sine wave, sawtooth, square wave. It's a signal generator. How very useful. That's a wonderful thing to have. Most pleasing. A signal generator, of all things. You're going to be in for a treat, because as I said earlier in the video, I do have my oscilloscope set up. So what better way, and what only way really, of seeing what signals were going to be produced. This could be a darn useful circuit after all. Right, so we have these components that we don't know the values of. We can kind of guess what they are, these sort of small variable resistors, but we don't really want to mess with them, especially if this is a signal generator. So what I'm going to do is just rotate them all the way to one side or t'other. And then what you're going to do is measure from that middle pin, and it'll be one of the outer pins, and you're not sure which one yet, depending on which way you've turned it. So you can see that says 17.9k in that direction, and 4.5. Yeah, what's 17 plus 4? About 21, right? So that's probably the 20k. So this, we know the other one will be 100-ish. 107, 1.3. Okay, so that's the 100k, that's the 20k. So the 20k was indeed the one that has the 2 in it, 203. So maybe, yeah, maybe, and the 104. So maybe they're rated a little bit bigger. But remember, they're variable, so they are going to be slightly out. It's just roughly 20k, roughly 100k. They don't need to be so exact because they're going to expect an operator to actually have to come in and tune that and calibrate them anyway. As to what exactly they do, I don't know. We're going to have to look up what that big IC is. But the fact that there exists an IC that controls all of these kind of signal outputs is really useful to know, because you never know when you're going to make a circuit that needs to have some sort of timing output of a particular wave style, and there you go, you've got it all in one in this package here, which we're about to insert. I think we're going to put the IC holder in next before we put our ports on, because the ports look like they're quite fiddly. Interesting. Again, look, we've got some pins here that don't have reciprocating pads. That's a very strange design choice. It really doesn't cost you anything to add. Remember, it's a subtractive process making PCBs. They start off with all the copper and then remove the copper with acids or whatever. So it doesn't cost you anything to have a pad there. So really, I would always put a pad even if it's not connected to anything, so at least you can solder to it. So at the moment you've got this device and 1, 2, 3, 4 pins of it aren't actually even supporting this holder. It's kind of a bit weird. I guess it's not really that big a deal on this whole scheme of things. I'm just resetting these variable resistors. In fact, that one's not quite sitting how I'd like it. There we go, now it is. Right, now we're going to be in business. Let's pop this in. Again, look, sort of dual footprinted here. You can see on the PCB that they're actually all hooked through, so it doesn't quite matter. Maybe there's a couple of different kinds of these, so they've just gone for the safest option and put both sets of holes. That's rather good. So I wonder what sort of adjustment we can make on this. It's quite interesting. It's almost like a real piece of kit, isn't it, as well? You could use this in your personal lab setting. Put it in a nice box. Oh! Looky-doo, look at this. See these headers? They've got a small keyway on the edge. They actually lock in together. Nice. That's so cool. I've converted it. Oh, beautiful, mate. You beaut. They've got some seriously robust terminals too. I'm going to put a bit of extra solder on those. That'll let them last all those yanking in the future. But because you've got all three ports locked together, that's going to be quite a substantially strong bit of kit. Soldering iron off. We're done. Let's get this in there. Just notice the switch on the unit has a mode A and a mode B. Intriguing. That's in. Let's get our power wires. And I'll just check our power supply is set to 12 volts before we turn it on. 12 volts plus. Hopefully some of these pots will let us change its frequency, and we can see if we actually look up the data sheet for one of these 8038 chips. That's it, actually, that's all we need. Just if we get our oscilloscope here and the probe edges, I'm just going to try to hook our... doesn't quite want to work, so what we'll do is we're going to get one of those handy component leads I was telling you to keep, like so, and then screw that in into the ground so we can put our probe on there. Nice and easy. So I've actually got this kind of upside down, but we'll work it out. So I'm going to just turn on the oscilloscope. Power's up, that's a great sign. Got the oscilloscope on. Let's start probing. All of these have been set now to the middle of their range. That one could just be a little bit more. And we're going to start off with the square wave, and I'm just going to poke that in. And I can see a square wave already, and I'm just going to very gently pinch that on the probe so it's not going anywhere. So we can sit back and have a look at the oscilloscope. So we're seeing 12 volts per division, well, 2 volts per division, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12 volts peak to peak, so it's showing that input voltage. So I'll actually lower the input voltage slightly. Okay, it starts to lose it a little bit under 5 volts, so it seems to have quite a wide voltage range. That's kind of useful to know, you know, if you're using this as part of something else. Definitely a square wave output. Maybe a little bit noisy. I'm not sure where that's coming from. You can see I'm touching it and it's doing all sorts of things. This first pot, let's see what that does. Not seeing anything off the 100k pot. Off the 20, let's have a go. Okay, the LED's on. I've got it hooked up to the square wave output. All the pots are set to their neutral positions, and you can see on the other there. Okay, the LED's on. The scope is on, it's all hooked up. We've got the scope probe on the square wave output, and on the scope you can see a square wave, fortunately. So look, you twist the big knob at the end and look, you can adjust the time base for that. Little square waves, big square waves. Let's try this smaller pot here, see what it does. Nada, nothing. Let's try this other pot here. This is the 20k one. Changes the shape, changes the duty cycle of the on-off ratio. Fantastic, works lovely. Mode A, mode B. Slower, bigger waves. So mode A and B are obviously like a sort of a shift between the different time bases. So if we max it out, you see how they're 42 kilohertz, and then as I twist it smaller, goes down to 625 hertz. Sorry, that's 42 hertz, not kilohertz. 42 hertz down to 624 hertz. Then when I switch it over, put it back to the slow end, then it goes from 462 hertz down to 6.8 kilohertz. So let's get this right. So you've got 6.8 up to 462 hertz, then down to 624 up to 42. So you've got a little bit of an overlap there, so you've got a nice range. If you look at the actual shape of the signals, it's not amazing. I wouldn't say it's amazing, and there's a bit of noise, but that could be coming from the power supply. You can see there's a strange bit of noise there. I'm not sure what this adjustment does. It doesn't even do anything. So let's move on to the sawtooth button. Just poke that through here. So again, 6.8 kilohertz down to 460 something. So it's probably about the same range. We won't really worry about that sort of level of detail. I want to play with these pots. Again, this pot doesn't seem to do anything on that mode. Yeah! So changing the duty cycle on a sawtooth, of course, changes the way it points. I suspect strongly that you could put a different value in for this 20k and you'll get a little bit more range out of this. And then let's put it into our sine wave and see if we can actually get anything that looks like a sine. Wow, it does look like a sine wave. It certainly is a sine wave, guys. Where's it gone? Where's it gone? Where's it gone? Oh yeah. Hang on. That's a bit better. Now we can see it nice and big. We've embiggened it. So again, let's try the 100k that doesn't seem to do anything. Oh, it does move it around. It is changing the shape slightly. I'm thinking we want it there, somewhere in the middle between the two. Can bend that sine wave, but we can get a pretty good one. 452 hertz down to 5.86 kilohertz in mode A, and then mode B 35.2 hertz, something like that, down to 532, or up to, depending which way you want to look at it. Fantastic. So yeah, that's a nice little bit of kit actually. Really useful. I'm going to enjoy playing with this. I think that you know, you can imagine this could be quite useful going forward, and actually will definitely, hopefully, take its pride of place on my shelf of curiosity. So one quick experiment though before we sign off. Let's try a speaker in here, because I think its output looks like it's basically reflecting whatever input's going in. It should be juicy enough to power something like a speaker. Okay, so I've hooked on some crocodile clips onto the outputs. You can see them right here. I've got a speaker. Just going to hook it up. I've left the red wire a bit loose. Ooh, there we go. How unpleasant. So you can hear the wave. So theoretically you might be able to drive this at ultrasonic frequency, so that would be fun if you've got an ultrasonic transducer. In fact, listen to that. Woohoo! That's pretty impressive. I can hear that. I don't know if you can. Nice. So you might be able to use this as part of your make a music generator, some synth going on. Let's try it in the other one. Sine wave, bit sort of cleaner sounding. Higher frequency. Harder to hear though, harder to hear. Square wave. Coming out louder. Nice. Yeah, baby, that's some 8-bit sounds. So, there you have it. This is one cool ass kit, an 8038, ICL 8038, which is clearly a signal generator IC. Absolutely marvelous. I think this is probably the most fun you're going to have in one of these kits, because not only can you look it up on an oscilloscope and look at all the goodies on the output, but you can also, of course, hear it. And I, for one, I'm really tempted to just sort of take a bunch of these chips and make my own sort of synth, you know, with 4 or 5 buttons that turn it on, and then you can have it all on parts and tune it all up. How groovy is that? www.66kv.cn. I'm going to try to post links down below to the kit itself. In fact, the kit has a number JZ160039. But yeah, if you're really up to it, just make your own circuit. Look at it, it's nothing. Go into a CAD package, make up your circuit. In fact, look right here. This is probably a reference design for this chip, but if not, you can see how this one works, and you can figure out how the switch is working. You can see here you've got a timing circuit basically that's probably coming off pin 12 and pin 10. These probably make up the oscillation, and when you're switching between the two, you're just choosing a different range. But look how close it is. Not much between them, mind, but you could probably have a variable capacitor in here if you really want to be able to adjust it fractionally. So yeah, hope that's been of some use to you. Please like my video, let me know if you've enjoyed it. Please comment down below, tell me what sort of videos you like, what you'd like me to make, what you'd like me to do with this perhaps. Click subscribe, and as ever, thank you for watching.